Good morning, grade 10. Let us see first theorem in this topic, that is related to similarity and right angle triangle. Now see students, when it comes to theorem, rather than remembering the whole proof of the theorem, it is important that what is output of the theorem or what this theorem says. In short, please remember mathematical, you may say, form of this theorem, or at the end what this theorem is going to tell you, because your problems will depend upon use of these theorems. So what is the mathematical statement, you may say, or form of this theorem? Please remember it. Okay, now let's start with the theorem. Now see, if there is a right angle triangle, first I'll explain you, then we'll go to the statement. This is a right angle triangle ABC, and if I draw segment BD such that BD is perpendicular to the hypotenuse AC. In triangle ABC, angle B is 90 degree and I have drawn segment BD perpendicular to segment AC. That means I have drawn an altitude from B on side AC. Alright, if this is the condition, then you get three triangles. This is first triangle ABD, second triangle DBC, this is second triangle, and third triangle is the original triangle, that is triangle ABC. So you have three triangles, 1, 2 and this bigger one. So if in a right angle triangle, if you draw altitude on the hypotenuse, then three triangles which are formed are similar to each other. It is as simple as that. Okay. So in a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. Or in short, all the three triangles are similar to each other. That is the theorem. So given is in triangle ABC, you have angle B is 90 degree. BD is perpendicular to AC such that A dash D dash C, and we have to prove that ABD, this triangle, is similar to bigger triangle, as well as triangle ADB is similar to bigger triangle ABC. Then second triangle, that is BDC, this smaller triangle, is also similar to triangle ABC, and these two triangles are also similar to each other. In short, we can prove triangle ABC similar to triangle ABD similar to triangle DBC. That is what we are going to prove. So proof is very easy. First you consider two triangles ADB, this triangle, and triangle ABC. Now in these two triangles, that is bigger triangle and this triangle, angle A is common to both of them. You may say angle A is common angle. When angle B is 90 degree, here angle D is 90 degree. Angle D and angle B, each is 90 degree. So by AA test of similarity, bigger triangle is similar to this triangle ADB. Okay. Similarly, with this triangle and big triangle, you have, if I consider ABC and if I consider another triangle, that is BDC, this small one and this big one. Now angle C is common to both of them. You can see angle C over here. Angle C is common angle in both of these triangles, this triangle and bigger triangle. In bigger triangle, angle B is 90 degree. In smaller triangle, angle D is 90 degree. So again, each measures 90 degree. So again, by AA test of similarity, triangle BDC is similar to triangle ABC. Now see, bigger triangle is similar to this one. Bigger triangle is also similar to this one. That means these two are similar to each other. Alright, if A is similar to B and B is similar to C, then A is similar to C. It is in that way. Alright, and therefore we have triangle ADB similar to triangle BDC from these two, because they both are similar to ABC. So we have ADB, this small triangle is similar to triangle BDC. These two are similar. Alright. And these two are similar to bigger one. So at the end what we get? ADB similar to BDC similar to ABC. Alright. All the three triangles will be similar to each other. Please remember this. Rather than theorems are important as from your scoring point of view, but you know there is only one question on theorem and that is also optional. So I will not suggest you do not learn the theorems. Theorems are important, but what is important is when right angle triangle is there and one altitude is drawn out the hypotenuse, you should know that all these three triangles are similar to each other, because that will be applicable in solving the problems. Application of theorem is more important. Alright, so you may pause the video and take down and remember this statement. Okay, let's go to the other theorem now. Now let's say second theorem, that is theorem of geometric mean. Now first of all, what do you mean by geometric mean? For example, in this triangle, that is RQP, angle Q is 90 degree. Alright. Now QS is again perpendicular, which is drawn at hypotenuse PR. Alright. Now if QS segment square, QS square is equal to RS into SP, then we say that QS is geometric mean of these two segments. Are you understanding me? Now, theorem of geometric mean. In a right angle triangle, the perpendicular segment to the hypotenuse, this is a right angle triangle, perpendicular segment which is drawn to the hypotenuse is QS. See, QS is perpendicular, so here I have shown 90 degree. From the opposite vertex of this is Q. Okay, so in a right angle triangle, perpendicular segment drawn to the hypotenuse from the opposite vertex. Q is opposite vertex of hypotenuse PR. Then this segment is geometric mean of the segments into which hypotenuse is divided. Hypotenuse is PR or RP and it is divided into two segments. One is SR and another is SP. Alright, so product of these two will be equal to square of QS. That is to say that QS is geometric mean of the two segments into which the hypotenuse is divided. Now, let us start with the proof now. In right angle triangle PQS, you know that QS is perpendicular to PR and therefore we know that these two triangles will be similar. Just before this we have seen similarity of right angle triangles. Okay, so by similarity of right angle triangles, we know that these two triangles will be similar to each other. So I have written triangle QSR. QSR is this triangle, is similar to triangle PSQ. Please see that one-to-one correspondence. Angle S is 90 degree over here, so S will be equal to S. Q will be having one-to-one correspondence with P. Okay, and Q will be having one-to-one correspondence with R. Mind well. Alright. So QSR, this triangle is similar to triangle PSQ. Okay. Now we know that in first topic we have learned if two triangles are similar, the corresponding sides are in proportion. Now this has already been written in the 1:1 proportion. Alright. And therefore QS upon PS, first two. QS upon PS will be equal to SR upon SQ. That is how you write sides in proportion, provided these three vertexes you are writing in one-to-one correspondence. That is very important. Alright, you can't write anyhow the name and then choose first two letters upon and then write the correspondence. This should be in one-to-one correspondence. Then you can write QS upon PS is equal to SR upon SQ. Now QS and SQ. See, QS and SQ is one and the same. So for SQ I can write SQS. Now if I cross multiply, I get QS into QS is equal to PS into SR. So QS into QS is QS square, which is equal to PS into SR. And once you get this, then you can say that QS is geometric mean of PS and SR. See, PS and SR. These are the two segments into which the hypotenuse is divided and it is equal to the square of this altitude drawn. Again, I am telling you students, what is important in this theorem? This expression, mathematical expression is very important. This is used to solve the problems. Okay, so what you should remember? QS square is equal to PS into SR. That will help you to solve the problems. Alright, and proof is also very easy. Okay, Fine. Now let's go to the next two concepts which are written in your textbook. A quick revision of Pythagoras theorem and converse of Pythagoras theorem. Students are always confused when to write theorem and when to write its converse. See students, in theorem, triangle 90-degree angle is given. Look here if and then, and look here if and then. If angle B is 90 degree, then AC square is equal to AB square upon BC square. So here angle right angle is given, or a triangle is right angle triangle, it is given. But if one of the side, square of one of the side is equal to sum of the squares of remaining two side, then that triangle is right angle triangle. That is, you are using converse of Pythagoras theorem. So in converse, you are proving that the given triangle is right angle triangle. And in theorem, it is already given that triangle is right angle triangle, and so the relation of sides is like this. Look here if and then, and look here if and then. If triangle is right angle triangle, then you have the relationship of sides. Here, if the relationship of sides is like this, then the triangle is right angle triangle. Then you have Q as 90 degree, and so this becomes right angle triangle. Alright, so please keep this in mind. Alright, this will be useful to to solve the problems. So that's all from my side for today, students. Thank you.